Piecewise linear function is going to be a function whose graph consists of straight line segments, typically defined with different equations for different parts of the domain. So in the first example, we want to graph the function f, where it's equal to x plus 2 on the interval where x is less than 0. And then it's going to be the rule 2 minus x when x is greater than or equal to 0. Okay, so think about this as sort of two different problems. So if I start with my function being x plus 2, that is only going to be true when x is when x is less than 0. Okay, since x is less than 0, are we including 0 when we graph it? No, so we're going to actually represent that on the graph as an open circle because it's not included. But when we create our ordered pairs and think about the domain here, we can include 0 as a starting point. Okay, so that can actually be a point on our line. So because I want values that are less than 0, when I choose points, I'm going to choose points that are less than 0. Okay, so that means negative values, right? So how about we do -2, -1, and 0. Okay. Of course, we just said that we're not going to include. So you're going to have an open circle on your graph. At that point, 0, whatever we find. Okay, so I'm going to take each value and I'm going to plug it into the function, just like we did before.
Why aren't you including?
Because it's strictly less than 0. If this had been less than or equal to, then we would include 0.
With the line under?
With the line under, yes, exactly. And then we would have a closed-in circle. So we'll do that on the second part. Yeah. So I'm going to substitute in -2. So -2 plus 2 is 0. Okay, so I'm forming ordered pairs, just like we did in the previous problem. -1 plus 2 is going to be 1. 0 plus 2 is 2. Okay, so I have 3 points to plot. So I have -2, 0, -1, 1, and then I have this point 0, 2. Now we said we're not including it, so on the graph, I'm going to draw an open circle at 0, 2. Okay. Now we understand that this is a line, but we only want this line where x is less than 0. So that means here's where x is 0, right? We only want to draw the line to the left of where x is 0, because that's where x is smaller than 0. Okay? So this rule only applies when x is less than 0. Okay? Now we look at the second piece of the graph, which is our function 2 minus x, where x is greater than or equal to 0. Okay? So now we're looking at ordered pairs. What is my starting point for this ordered pair? 0, right? Okay, because we start at 0 and we are including 0 this time because it's greater than or equal to. So greater than or equal to. So I'm going to start with 0 and I want values that are bigger. So let me do 1 and 2. All right, so I'm going to include, so we want to include the 0, which means when we draw it on the graph, we're going to have a closed circle. Okay, so let's find these ordered pairs. We substitute in 0. So 2 minus 0 is 2. 2 minus 1 is 1. And 2 minus 2 is 0. Okay, so I have this point 0, 2. So we just graphed it with an open circle in the last piece, but what can we do now? Color it in, because now we're including it. Okay, then we have the point 1, 1, and we have the point to 0. And so there's the graph of my function. It's actually called an absolute value function. This one's reflected, but it's an absolute value function.